so the first example tells us to solve for 0 degrees is less than or equal to x, which is less than 360 degrees. So most of the time when we've been doing our equations, we have always given our answer in radians. But because of the way that these instructions are given, this equation we are going to answer in degrees. So let's start the same way that we've been starting. We have one trig function, so we want to isolate that. So in this case, we would begin by adding 1 to both sides. So we have 5 sine of x is equal to 4. I had parentheses around the x in the original problem. Technically, they're not really necessary because it's just that x. It does help indicate to you that that minus 1 is outside of the trig function, not inside the trig function. So once I move that 1, I really don't need the parentheses. If you want to keep the parentheses, that's fine. There's nothing wrong with that. But I'm just going to drop them in my problem. Then we divide by 5. So we get the sine of x is equal to 4 over 5. Now, we haven't done anything wrong in our steps of solving. Adding 1 was the correct step. Dividing by 5 was the correct step. But 4 over 5 is not our unit circle. Well, guess what? Trig functions are not limited to the values that are on the unit circle. They can have more values than square root 2, 1/2, square root 2 over 2, etc. As long as they are less than 1, or as long as they are between -1 and +1. Is 4/5 between -1 and +1? Yes. Okay, so how do we handle it? It's not an angle on the unit circle. Think back to Math 2, when you were solving right triangles, and you had to solve for the angle of the triangle. Not solving for a leg, but you were solving for an angle. That's what we're doing right here. We are solving for that angle. Does anybody remember what you did in that case? Yes, sine to the -1. It was the inverse, okay? We use the inverse function. We use the inverse trig function in our calculator, okay? The reason why we do that is because we're doing the opposite here, okay? The step right before the last step that I have written up here is saying that the sine of an angle is equal to 4 over 5. Well, we're flipping that relationship. We're saying, okay, well, the angle is equal to the inverse sine of 4 over 5. So we're doing the opposite. Inverses are opposites. That's what we're doing here. So a couple of things. In your calculator, our answer is supposed to be in degrees, so you need to change the mode to degree mode. If you do not change the mode, the angle that it's going to give you is in radians, and that's not what we want. We want degrees. The inverse sine is second sine. That will automatically pop up with sine to the -1. Okay, it's not actually the -1 power, it's just the inverse. And you type in the 4 over 5, and you get your answer. X is equal to 53.13 degrees. Now, when we were doing these problems the last 2 or 3 days here, we've always had more than one answer. Well, the calculator is only going to give you one answer. So let's think through, how can I come up with the other answers? So I'm going to draw myself a little picture here. Okay, 4 over 5, okay, that would be a triangle in the first quadrant, right? Positive, positive. That's where sine is positive, right? In the first quadrant. It has a y coordinate of 4 over 5. I don't know what the x coordinate is, it doesn't matter. But I know the y coordinate is 4 over 5 because the sine of that angle is 4 over 5. So that's 53.13 degrees right here. Where else is the sine positive? What other quadrant? The second. So we draw the exact same triangle over here in the second quadrant. And I didn't do a very good job. Mine are not exactly the same size. But they are mirror images of each other, right? So this 53 degrees is the same right here. 53.13 degrees is right there. How do we find the measure of that angle from the positive x-axis? Okay, this is going back to that reference angle idea. Subtract from 180. 180 minus 53.13 degrees is going to give us our other angle here. So 126.87 degrees is another angle that is the solution to this problem. Check it. Go back to the original. 5 sine 126.87 minus 1. Now, if this is an approximation, okay, I had to round, so it's not going to give me exactly 3, but it's pretty close, right? 2.99999. That's really close to 3. And this, a similar thing would happen when I plug in the 53.13. Now, if I took that exact answer from the very beginning up there, it would give me exactly 3. But because I rounded, it's just going to be really, really close to 3. Okay? All right. Now, what if we have one and it wants us to solve in radians? It wants us to solve this in radians. We've got 16 cosine of x plus 8 is equal to 2. So that means that we need to go to our calculator and we switch it back to radian mode. Okay. All right. So solve it just like we have been. We need to start by subtracting that 8. We've got 16 cosine of x is equal to negative 6. Divide by 16. So cosine of x is equal to negative 3 over 8. We do the inverse cosine of that number because that is not on our unit circle, but it is between negative 1 and positive 1. So we can use our calculator. Inverse cosine, I already changed mine to radians, so I'm where I need to be. Inverse cosine of negative 3 over 8. My angle is 1.955 radians. Now, we're not used to radians not being in terms of pi, but that's okay. Technically, that's between 0 and 2 pi. 2 pi would be 2 times 3. Well, I could do 2 times pi. That would be smart to use the one on the calculator. 2 times pi, 6.283. So we're within that range. Okay. So let's think here. We've got cosine is negative. That would be here in the second quadrant. That's that angle that they're giving us right there. This is the 1.955. Okay. Where else is cosine negative? Third quadrant. Okay, the x-coordinate is also negative in the third quadrant. So if we put this 1.955 down here, make it negative, how can we find the positive angle? Right here. If there's a negative angle, okay, if this is a negative angle, but we want the positive version of that angle, coterminal angle, right? Add 2 pi. So let's see here. Negative 1.955 plus 2 pi. 4.328. 4.328 is the other possibility. Check it. Okay, when in doubt, always plug it back in. 16 cosine 1.955, close the parentheses, plus 8. Okay, a little bit over 2 this time. Sometimes it just really depends on the rounding, whether it'll be over or under exactly what it's supposed to be. And then the 4.328, again, really, really, really close to 2. If we use the exact value, didn't round it, it would give us exactly 2.